Okay. So the next topic which we are studying is electromagnetic induction. So very easy topic, one of the easiest topic of physics, and very interesting also. And you will get 1 or 2 questions from this topic. Clear, ma? So, see, ma, in magnetic effects, what we have studied, in magnetic effects of current, we studied that current carrying conductor produces magnetic field, no? This is what we have studied, no? So if this is a current carrying conductor, so every current carrying conductor produces a magnetic field. And direction of magnetic field is given by right hand grip rule. So from top to bottom, we are curling from outside the board, we are curling from top to bottom. So this is the orientation of magnetic line, and this is the orientation of magnetic line inside the board. This is what we have studied, no? So therefore we study that current produces what? Magnetic field. This is what we have studied. Clear, no? Current definitely produces magnetic field. Now the question is, will magnetic field produce current or not? Okay, ma? So magnetic field, will it produce current or not? That is the question. So definitely we have understood that there is a relation between electric field and magnetic field. Current carrying conductor is producing magnetic field. Now the question is, magnetic field, will it produce current or not? Clear? So for that we have done some experiments. Now what we have done, we have taken a coil. Clear? And to this coil we have connected a galvanometer like this. What is a galvanometer? It measures very small amount of currents. No? Very small amount of currents can be measured by galvanometer. So here I am placing a magnet, north pole and south pole, like this. Clear? Now here what is happening? Sima, magnet produces magnetic lines of force. No? For example, let us consider this is north pole and this is south pole. So magnetic lines continuously they travel from north pole to south pole. This is the orientation of magnetic lines of force. So definitely some of the magnetic lines, they will touch this coil also, no? Clear, no? Some magnetic lines are traveling like this, and some magnetic lines will definitely touch the coil also. So now the question is whether this magnetic field, the field produced by the magnet, can it produce some deflection in the galvanometer or not? Clear, no? If galvanometer deflects, then what I understand, for example, this is the initial position of galvanometer. If galvanometer deflects, then definitely I can say that a current is flowing in this circuit. If there is no deflection, there is no current. This is a closed loop. Current always flows in a closed loop only, no? Clear? Now what I observe is that here when I place this magnet with a magnetic field near a coil, I don't see any deflection. Okay, ma'am? So what is the note point we have observed? Note point is that if there is no relative motion, between magnet and coil, clear, ma? Then galvanometer reading is how much? Galvanometer reading is 0. Are you able to understand? So what is meant by relative motion, ma? First make a note up to here. Okay. So therefore, Sima, now can you say what is meant by relative motion? Relative motion means what? Second body is at rest position. Okay. Sima, for example, this is a magnet. Let us take case number 1. Clear? In case number 1, this is the magnet, south pole, north pole, and this is a coil. Clear? I see that both of them, they are traveling with a speed of 2 meters per second. Okay. So magnet is also moving with a speed of 2 meters per second. Coil also moving with a speed of 2 meters per second. Then can you say, will there be any deflection in this galvanometer or not? There is no deflection. So Ig will be 0. If both of them, they are traveling with the same speed in same direction, relative motion is 0, relative velocity is 0, no? What is the relative velocity of magnet with respect to coil? 2 minus 2, 0. Clear, no? Case number 2. Case number 2 is, I see that, clear, ma? This is the coil. This is the galvanometer. And let us consider directions also. This is the initial position of galvanometer. Now I see that only magnet is moving, coil is in rest position. Now is there any relative motion or not? Definitely there is some relative motion. No? So I see that there will be some deflection in the galvanometer. Are you able to understand? No? So Ig value is not 0. What is meant by Ig value is not 0? Current is flowing in the circuit. And let us suppose this is the direction of current. Case number 2. Case number 3 is, clear, ma? So this is a magnet. This is a coil. Clear, ma? Okay. Now what is happening? Now this, what you say, magnet is moving in opposite direction. And this coil is in rest position. Now can you say, will there be any current or not? ఎప్పుడు ఉంటుందా ఉండదు? ఉంటుంది. ఎందుకలా? ఆ కాన్సెప్ట్ ప్రకారం చెప్పండి. మనం దేని గురించి మాట్లాడుతూ ఉన్నామో దాని అప్లికేషనే మాట్లాడాలి. మన సొంత ప్రయోగాలు చేయకూడదు. మనం దేని గురించి మాట్లాడుతూ ఉన్నాం? ఇస్ దేర్ ఎనీ రిలేటివ్ మోషన్ ఆర్ నాట్? No. So if magnet is moving in opposite direction and coil is in rest position, here also definitely there is some relative motion. Clear, no? Relative motion is definitely present. And now I see that because magnet is moving in opposite direction, the direction of current also has reversed. And I see that now current is flowing in opposite direction. It means now deflection is in this direction. Are you able to understand? No? So therefore, if direction of magnet changes, then also the direction of current also will change, and current has definitely produced. Are you able to understand why current has produced? Because there is some relative motion between the magnet and the coil. So here also I say that Ig value is not 0. Clear? Let us draw one more case. Case number 4. Okay, ma? Case number 4 is, now this is the magnet, north pole and south pole. This is the coil. Clear, ma? So this is the galvanometer scale. Now magnet is in rest position and coil is moving in this direction. Now will current be produced or not? Huh? How can you say? Relative motion is there, no? Now can you say what will be the direction of current, ma? This direction or this direction? This direction. No. Direction of current will be this direction. Why? Because previously here north pole was approaching the coil, no? Now also north pole is approaching the coil. Clear? So here this will be the direction of current, and this is the deflection of the pointer. Clear? Case number 5. Okay, ma? Again I take magnet is in rest position. Clear? This is the coil. Now can you say this is in rest position? Now coil is moving away from this north pole. Clear, ma? Now again I see this is equivalent to this condition, no? North pole is moving away from the coil. Same condition here also. So therefore here if I suppose this is the direction of current, here also same direction of current. This is the direction of the point. Are you able to understand? So by doing all these experiments, what we have understood, we understand that whenever there is a relative motion between the magnet and the coil, then definitely I can say that current is produced in the coil. But if both of them they are in rest position, so let us write that case also, case number 6. Case number 6. Clear, na? So this is the magnet, this is the coil. Okay, magnet is also in rest position, coil is also in rest position. Now I don't see any deflection in the galvanometer. So whenever you find relative motion, definitely current will be produced. Are you able to understand? So first make a note up to here, then we will see. Sima. So therefore, by doing all these experiments, what we have understood, can you say anybody? In which condition current is produced? In which? Very good. Sima. So therefore, when you see here, magnet is in rest position, coil is also in rest position. Clear, no? Now what is happening here? Here, some of the magnetic lines, they are touching the coil, no? Clear, no? So what happens? Some magnetic lines are touching the coil. Okay? So if magnetic lines are touching the coil, is current produced? Current produce అవుతుందా అవుతుందా చెప్పదు త్వరగా చెప్పండి గట్టి. ఎవరైనా తప్పు చెప్తే మటర్ చేస్తారు, ఎవరో చెప్పినారా మిమ్మల్ని? Both of them, they are in rest position. So current is not produced. That's what we have been discussing, no? Current in the galvanometer is 0. Clear? So it means that, so it does not depend upon whether magnetic lines are touching the coil or not. So current produced does not depend upon how many magnetic lines are touching the coil. Okay? Then in which condition current is produced? Current is produced in that condition when number of magnetic lines which are touching the coil, they are changing. Are you able to understand, ma? See, ma, if you move the magnet closer to the coil, then what happens? See, let us draw a magnetic field here. So this is how field appears, no? This is how field appears. Okay? Like this. So if there is a coil present here, how many lines it is touching? Approximately we are saying, so 1, 2, 3 lines only it is touching. Clear, no? But if I take this magnet closer to the coil, for example, if coil is now present here, now how many lines it is touching? Okay, so 1, 2, 3, 4, 5, 6 lines it is touching. So when it is closer to the magnet or when it is farther away from the magnet, in which condition current is produced? Coil magnet ki దూరం ఉన్నప్పుడు కరెంట్ ప్రొడ్యూస్ అవుతుందా, దగ్గర ఉన్నప్పుడు కరెంట్ ప్రొడ్యూస్ అవుతుందా? When, see, this is the coil in rest position and it is very far away from the magnet. How many lines are touching? 1, 2, 3 lines only touching. Now when I keep this magnet closer to the magnet, coil closer to this magnet, then I see many lines are touching. So in which condition there is a possibility that current is produced? Chapandi. Oh. So did I say that if coil is closer to the magnet, current is produced? Cheppina na statement emanna? Mari meer etla cheptaru? I am not moving. Okay, ma? Initially I am placing the coil far away and I am checking the current. Then I am placing the coil very close. Then I am checking the current. I am not studying about movement. I am studying about position. First position, second position. In which condition current will be produced? Movement gurinchi maatladam ledhu. I am discussing only about first position and second position. In which position current will be produced, or it will be produced in both conditions? Current will be 0 in both the conditions. Clear, ma? When you keep the coil far away from the magnet, no current. When you keep the coil closer to the magnet, then also no current. Okay, ma? So therefore what I understand that current produced does not depend upon position of the coil. Are you able to understand? So if it is not depending upon position, it also means that current produced does not depend upon how many magnetic lines are touching the coil. So if only 3 magnetic lines are producing, then also no current. 6 magnetic lines are touching the coil, then also no current. So what I understand? So these inferences I will write here. These are very, very, very important. Clear, na? Note point is that current produced does not depend on how many magnetic lines are touching the coil. Okay, ma'am? That is, it does not depend on distance between coil and magnet. Are you able to understand, ma'am? So whether it is closer to the magnet, current produced is 0. If it is farther away from the magnet, then also current produced is 0. So in which condition current is produced? మరి ఎప్పుడు ప్రొడ్యూస్ అవుతుంది? మూమెంట్ ఉన్నప్పుడు. దట్ ఈస్ ద పాయింట్ విచ్ వీ షుడ్ అండర్స్టాండ్. కైకు కతో ఒత్తాచో. Clear ba? See, reason for this one is any matter always wants to be in rest position. Able to understand ma? Suprajaki intiki poi padukomante aanandam anamata. Because she will be in rest position. Are able to understand ma? If I give you work suddenly, you will oppose. That is called as inertia. So inertia is not applicable only in Newton's laws only. Inertia is applicable for everybody, for human bodies also. Are you able to understand, ma? Similarly, same concept here also. When magnetic lines are touching the coil, no problem. But magnetic lines, when they are changing, coil does not want the magnetic lines to change. Okay? So if less magnetic lines are touching, okay, no problem. If more are touching, no problem. But if lines, if they are changing, that is not bearable by the coil. That is called as inertia. So here also coil has a property called inertia. Magnetic lines మారుతూ ఉన్నాయనుకోండి, మంట పడుతుందని. Okay? So why it happens, we will discuss afterwards. Clear, ma? So what we have written? So it does not depend upon how many magnetic lines are touching. Then it depends on what? It depends on current produced depends on. Okay, ma? Current produced depends on what? Current produced or depends on how fast magnetic lines touching the coil, how fast magnetic lines touching the coil are changing with respect to time. Okay, ma? So current produced depends on only one factor. What is that? How speedily the magnetic lines which are touching the coil, they are changing with respect to time. Okay, ma? See, if you bring the magnet very close to the coil, very less amount of current will be produced. But if you move the magnet very fast, then you see that more amount of current will be produced. What is the reason? Speed. If speed increases, what happens? If speed increases, the number of magnetic lines which are touching the coil, they will increase. Are you able to understand, ma? So automatically current also increases in the coil. So that is the point which is producing current in the coil. Clear, ma? So what is the point which you should remember? How fast magnetic lines that are touching the coil, they are changing with respect to time. Are you able to understand? मैं बोला है तुमसे, तुमने तो बोला है तो कंपलसरी सीक्रेट्स तुम्हारे कान में बोला है तो आको भाई. how ham bhi depend होता है नहीं, makeup बोलो depend होती है को. It does not depend how many magnetic lines are touching the coil. It doesn't depend. It depends on what? Depends on how fast the magnetic lines are changing. है क्या है बोलो? How fast magnetic lines are changing with respect to coil. Are you able to understand? So it depends on change of magnetic lines. Initially only 10 lines were touching. Now you have brought the magnet very close to the coil. Clear? In that process, when it is coming, then what is happening? Number of magnetic lines, they are increasing, no? 10, 20, 30, 40, 60,000. So change is happening, no? That change produces current. Are you able to understand? మీరు ఇంట్లో ప్రశాంతంగా పనుకొని ఉన్నారు, పడుకొని ఉన్నంత వరకు ప్రాబ్లం లేదు. వర్క్ ఇచ్చినాను అనుకోండి, మీరు అపోజ్ చేస్తారనమాట. అట్లా లేదు, ఇంకో విధంగా చెప్పాలంటే ప్రశాంతంగా బయాలజీ చదువుకుంటూ ఉన్నారు మీరు, సరదాగా అట్లా సడన్గా వచ్చి నేను ఫిజిక్స్ ఇచ్చినాను మీకు, అయిపోయి ఒకసారి ఫేస్లో ఎక్స్ప్రెషన్స్ మారిపోతాయి అనమాట. ఇప్పుడు దాకా ఏదో ప్రశాంతంగా చదివేవాళ్ళు ఫిజిక్స్ వచ్చిందిరా మా ప్రాణానికి అట్లా. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో దేర్ ఫోర్, so current produced depends on what? Depends on how speed magnetic lines are changing. Okay, no? See, if magnet and coil, if they are, both of them are in rest position, then also magnetic lines are touching the coil, no? But current is not produced because magnetic lines are not changing, they are constant. Okay, and less number of lines are touching, more number of lines are touching, it doesn't depend on that. It depends only on what? Magnetic lines, whether they are changing or not. It depends only on that. Clear? So therefore, for example, if this is a magnet and this is a coil, clear ma? So if magnet is moving with a speed of 2 meters per second, then current produced is 10 amperes of current, for example. Okay ma? 10 is very large, 1 ampere of current. Clear ma? And if this is same magnet, if it is moving with a speed of 10 meters per second, then the amount of current produced is very large. So I1, I2 is equals to 5 amperes of current. So this change you can observe. Okay ma? So what is the difference between both of them? So here magnet is moving slowly with a speed of 2 meters per second. Then I see that current produced is also lesser. But in the second condition, magnet is moving very fast. So the amount of current produced is also greater. Are you able to understand? Why it is like this? Because here the number of magnetic lines which are touching the coil, they will change slowly. Okay? But here number of lines which are touching the coil, they will increase very fast. So current produced is also very fast. Are you able to understand? That's it. Okay? So now see, my point is that in which condition current will be produced? Current asal eppudu produce avutundi? In which condition current flows in a coil? वो हो गया जी, मामूल से करंट कब फ्लो होता है बोलो? Why current is flowing in our room? Because there is a potential difference. Are you able to understand ma? So therefore, the most important point is that current flows only if there is a potential difference. Only if there is a potential difference. That's all, no? See, this is a resistor, this is a wire. Now will current flow here? Flow avadu. Enduku flow avadu? What is meant by potential difference? Battery is the source of potential difference. No? Here current cannot flow because there is no battery. Clear ma? So here I produced is 0. But in the same circuit, if you place a source of potential difference, now this is a battery, this is at a higher potential, this is at a lower potential. So there is a potential difference. No? So because of that, this current starts flowing in the circuit. So here also if current is produced, then what is the meaning of it? If current is produced, it means that inside the coil potential difference has developed, or you can say EMF has developed in the circuit. Clear now? So therefore but I can say relative motion between magnet and coil relative motion between magnet and coil is producing EMF in the coil. Okay, ma? So a source of potential difference has developed in the coil. Clear, ma? Okay. Understood, Nama, what is happening? So therefore, you can say it is as if a battery is connected in this coil. If you place a battery, current starts flowing. No? So you can assume this coil as if some battery has been induced in this coil. Okay, battery undemo annatluga current flow avutundi. Are you able to understand? That's it. Now the question is, this amount of EMF induced depends on what? EMF is nothing but you can say it is potential difference. No? Don't be confused. We are not discussing about electric field. We are discussing about potential difference. There is a lot of difference between EMF and electric field. No? Electric field is force experienced per unit charge. But what is potential difference? Work done per unit charge. We are not discussing about electric field here, but we represent by E only. Okay? That's it. So therefore, here we will study Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. So all these experiments, it was done by Faraday, Michael Faraday. Do you know who is Michael Faraday? తెలుసా? నాకు కూడా తెలియదు, మా పక్కింటోడు ఎవరో తెలియడానికి, నాకు కూడా తెలియదు. క్లియర్? So Faraday's laws of electromagnetic induction. First law. Same, whatever we have discussed, that is our first law. If there is relative motion between magnet and coil, then EMF is induced. EMF is induced. Oh. Okay, same. So this is our first law. Already we studied this one. No? Whenever there is a relative motion between magnet and coil, then EMF will be induced. EMF is nothing but potential difference. Don't be confused. We call it as E also, we call it as V also. Both are same. Clear? And there is some continuation also. And if coil is closed, clear, ma? Then current starts flowing. Then current starts flowing. Are you able to understand, ma? See, if EMF is induced and if coil is an open circuit, then current cannot flow, no? See here, I am connecting a battery and here I have opened the circuit. Now current can it flow? Current cannot flow. So same point he is saying. EMF will be definitely induced, whether it is an open coil or whether it is a closed coil. But current flows in which condition? Current flows only if coil is a closed coil. Are you able to understand? This is my first law, not my law, Faraday's law. Second law is that EMF induced is directly proportional to minus d pi divided by dt. This is called as second law of electromagnetic induction. Okay, ma? What is meant by E here is called as EMF produced in the coil, or you can say potential difference developed in the coil. This is directly proportional to what? D pi. What is meant by D pi? D pi is nothing but change in flux. Change in magnetic flux. Okay, ma? And what is meant by magnetic flux, ma? Electric flux we have studied. No? How many magnetic lines there are passing through a unit cross section, that is called as magnetic flux. Okay? If 10 lines are passing per unit area, then magnetic flux is 10 like that. It will be in millions and millions. Just for your explanation I am saying. And what is meant by dt? Change in time. Dt is called as rate, or you can call it as change in time. Okay? So therefore, EMF induced is directly proportional to rate of change of flux. So write the statement also. So EMF induced is directly proportional to rate of change of flux. Which flux? Magnetic flux. Okay, ma? And I can remove this proportionality symbol also, ma, and place 1 as a constant. So E is equals to minus n d pi divided by dt. I can write like this also, where n is called as number of turns which are present in the coil. Okay, ma? So if there is only one turn, you can just write E is equal to minus d pi by dt. If there are two turns, 2 into d pi by dt. N number of turns, n into d pi by dt. That's it. Okay. So this is about the two statements which are given by Michael Faraday. Clear, ma? First law is that there should be relative motion. If there is relative motion, this is the amount of EMF which is produced. Okay. So when you look at the statement, what do you understand? If d pi is 0, what is d pi? Change in flux. It means if flux does not change, then EMF will be 0. Flux must change. It means there must be relative motion between the coil and the magnet. Clear, ba? And if dt is greater, or if dt is smaller, what is meant by dt is smaller? Time is very small. If time is very small, then EMF produced will be very large. Okay, ma? If a flux is changing in a very small time, it means you are moving the magnet very fast. Ade kada dan artham. It means EMF induced also will be very large. That's it. Okay, ma? So these are the two statements which were given by Michael Faraday. Okay. Now after this, now the question is that current flows in which direction? That is important. Current flows in which direction? Okay. So it can be explained by two laws. It is given by, first one is called Lenz law. Second one is called Ampere's right hand rule. Okay. In magnetic effects, we studied Fleming's, not Ampere's, Fleming's. Okay. In magnetic effects, we studied Fleming's left hand rule, no? Huh? Now here we study Fleming's right hand rule. In magnetic effects, left hand. In electromagnetic induction, right hand. You can remember like that. Okay. Now first of all, we will study Lenz law. Then afterwards, we will study Fleming's right hand rule. So what does Lenz law give? It gives a direction of current. Current flows in which direction? Okay. Now let us see. So Lenz law says that, okay, so the EMF induced is such that it opposes the change that is producing it. This is called as Lenz law. Okay. There are many forms of Lenz law. I am writing in this form. Okay. So what does Lenz law say? Lenz law says that EMF induced in the coil will be in such a direction so as to oppose the change which is producing that EMF. It means EMF. Leach-Hatlier's principle we have studied now in chemistry. What is Leach-Hatlier's principle? Pressure, temperature, concentration, if they change, equilibrium will shift in that direction so that this change is opposed. Same concept here also. Clear, ma? So EMF will be induced in that direction and current flows in that particular direction so as to oppose the change which is producing that change in EMF. that producing that EMF. That's it. See, ma'am. Let us try to understand by taking an example. So here, north pole, south pole, this is the coil. Okay, ma'am? And this is the galvanometer. Okay? Now, north pole is approaching the coil. If both of them they are in rest position, no problem. Iddaru rest lo unnaru anukondi, okay, fine, no problem. But if north pole approaches this coil, now what is the change which is happening here? Change is what here? Change is north pole approaching the coil. This is the change, no? North pole approaching the coil. This is the change. Are you able to understand? అదే కదా మార్పు ఇక్కడ జరుగుతున్నది. నార్త్ పోల్ కాయిల్ వైపు వెళ్ళడమే మార్పు ఇక్కడ. బట్ కాయిల్ డస్ నాట్ వాంట్ దిస్ చేంజ్. కాయిల్ డస్ నాట్ వాంట్ ద నార్త్ పోల్ టు అప్రోచ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో దేర్ ఫోర్ వాట్ కాయిల్ విల్ డూ? కాయిల్ అపోజెస్ నార్త్ పోల్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో కెన్ యూ సే హౌ ఇట్ కెన్ అపోజ్ నార్త్ పోల్? నార్త్ పోల్ని అది ఎలా అపోజ్ చేస్తుంది? సో దెర్ ఆర్ 3 మెథడ్స్. ఇఫ్ కాయిల్ హ్యాస్ 2 hands, it will push the magnet away. Okay? Second method is, it will go to police station and it will complain. North pole is approaching me, I don't want the north pole to approach. Clear? Another method is, that method we are going to discuss. Clear, ma? So coil does not have any hands, no? So it cannot oppose the north pole. Unfortunately, it cannot go to police station also, no? So that also not possible. Then what is the method of opposing, can you say? This coil, how it can oppose this magnet? కరెంటుకి నార్త్ పోల్ రావడానికి ఏమన్నా సంబంధం ఉందా? చెప్పండి. దట్ ఈస్ ద కాన్సెప్ట్. సో this side of the coil, if it develops north pole, are you able to understand, ma? This side of the coil, which side? The side where north pole is approaching. If this side develops north pole, then there is repulsion between north pole and north pole, no? That is the method of opposing. Okay? So how it will oppose? It opposes by developing north pole. This is the method of opposition. Okay, ma? And can you say north pole, how it can develop, ma? How coil can develop north pole? In magnetic effects of current we have studied. Can you say? Coil can develop north pole and south pole also, no? How coil can develop north pole? See, ma? This coil, if I look from this side, then coil appears like this, no? ఈ వైపు నుంచి చూస్తే కాయిల్ ఇట్లే కదా కనిపించదు. ఇప్పటి నుంచి చూస్తే స్ప్రింగ్ లాగా ఉంటుంది, ఈ వైపు నుంచి చూస్తే సర్కిల్ లాగా కనిపిస్తుంది. అండ్ దిస్ సైడ్ షుడ్ డెవలప్ నార్త్ పోల్. దిస్ ఇస్ వాట్ వీ హ్యావ్ స్టడీడ్, నో? ఇఫ్ దిస్ ఈజ్ నార్త్ పోల్ క్యాన్ బీ డెవలప్డ్ ఓన్లీ if this coil flows some current. And this is the direction of current. Okay? If this is the direction of current, already we have studied, no, ma? Clear? So place your right hand in front of the coil, right hand palm rule in magnetic effects. What is right hand palm rule? Place your right hand in front of the coil like this. Clear, no, ma? Now this is the direction of current, no? Curl your fingers in the direction of current. What is the direction of thumb? Thumb is perpendicular and out of the board. Then what is the pole developed there? North pole. Are you able to understand? It means that this coil, this side of the coil, if you look from this side, then you see that this will be the direction of current. Are you able to understand? And automatically north pole is developed. Okay, if north pole is developed, now this is opposing this north pole which is approaching it. That is the method of opposing the change which is producing it. It means magnetic field. Is it clear? That's it. Okay, ma? Therefore I say that current is produced in this direction. So if current is produced in this direction and if it is a north pole, then can you say what is the orientation of magnetic lines? Magnetic lines will be in which direction? See, on this side if it is north, definitely this side should behave like south, no? ఓకే, ఇద్దరు పెళ్లి చేసుకున్నారంటే అర్థమేమి? మోగానికి పెళ్ళయిందంటే మర్యాదగా ఆడమకు కూడా పెళ్ళయిందని అర్థం, అంతే కదా? లేదంటే నా పెళ్ళి రేపు, నా పెళ్లి కూతురు పెళ్ళి మొన్నాడు జరగదు కదా. సో ఇఫ్ ఇట్ ఈస్ నార్త్ పోల్, ఇట్ మీన్స్ డెఫినెట్లీ హియర్ సౌత్ పోల్ ఈజ్ ఆల్సో డెవలప్డ్. ఓకే, నౌ హియర్ దిస్ కాయిల్ ఈస్ బిహేవింగ్ లైక్ వాట్? Magnet. Now can you say what is the direction of magnetic lines? Direction of magnetic lines is from north pole to south pole. Clear, Nama? This is the direction of magnetic lines, no? Okay. Now can you say what these magnetic lines are doing, ma? What these magnetic lines are doing? Can you say? These magnetic lines, they are opposing the magnetic lines produced by the north pole. Are you able to understand? See here. This is north pole. From the north pole, magnetic lines will be in which direction? In this direction. This is the direction of magnetic lines, no? And when it is approaching the coil, what coil will do? Coil will also produce magnetic lines. But in which direction? Such that it opposes the magnetic lines produced by the coil. Direction, student. Why it is opposing? Because that is its property. Okay, ma? So whatever you do, always coil will oppose. Okay? Is it clear, ma, what is happening? So therefore what? So in another method, how can I say? Second method of explanation, I can say that. Okay, ma? Second method is that. So the magnetic lines produced by coil, magnetic lines produced by coil opposes the magnetic lines, okay, ma? Produced by north pole. This is second method of explanation how coil opposes north pole. అర్థమవుతుంది కదమ్మా? కాయిల్ నార్త్ పోల్ని ఎలా అపోజ్ చేస్తుందంటే నార్త్ పోల్ డెవలప్ చేయటం వల్ల. నార్త్ పోల్ డెవలప్ చేస్తే ఏమవుతుంది? మ్యాగ్నెటిక్ లైన్స్ ఇట్లా వస్తూ ఉన్నాయి, కాయిల్ మ్యాగ్నెటిక్ లైన్స్ ఆపోజిట్ డైరెక్షన్లో వెళ్తాయి, వెళ్ళి రెండు మ్యాగ్నెటిక్ లైన్స్ క్యాన్సిల్ అవుతాయి. ఓకే, దట్ ఈస్ వాట్ ఈస్ హ్యాపెనింగ్. మేక్ ఎ నోట్ అప్ టు హియర్. నౌ సీ, సో ఇన్ ద ఫస్ట్ కండిషన్ what is the case we have taken? North pole approaching the coil. Clear? Now what is the second case I am taking? Case number 2 is north pole moving away from the coil. Now you have to say what is the direction of current, what is the direction of magnetic lines, and how Lenz law is applied. Okay? Okay? Sima. So in the first condition we studied that north pole was approaching the coil, no? What was the change there? అక్కడ జరుపుతున్న మార్పు ఏది? What was the change in the first condition? North pole approaching the coil. That was the change. Here what is the change? North pole moving away from the coil. And coil opposes any change. So it doesn't want the north pole to move away. అది ఇక్కడ మార్పు. అర్థమవుతుంది కదా? సో సిమ్, ఐ విల్ ఎక్స్ప్లెయిన్ ఇట్ బై అన్ ఎగ్జాంపుల్. సో యు ఆర్ వెరీ మచ్ ఇంప్రెస్డ్ బై మై టీచింగ్ అనుకోండి. ఓకే, రేపు పొద్దున పోయి ఒక 10,000 రూపాయల గిఫ్ట్ కొనుక్కొని వచ్చినారు. నిజంగానే కొనుక్కొని రావకండి, వచ్చినా నేనే ఫీల్ గాను అనుకోండి. 10,000 రూపాయల గిఫ్ట్ కొనుక్కొని వచ్చినారు అనుకోండి. మీరు నాకు ఇచ్చే ప్రయత్నం చేస్తారు, నేను అపోజ్ చేస్తాను. నో, ఐ కెనాట్ యాక్సెప్ట్ గిఫ్ట్ ఫ్రమ్ ద స్టూడెంట్. కానీ నా అపోజింగ్ ఫోర్స్ కన్నా మీ ఫోర్స్ ఎక్కువ ఉంది. సరేలే అని తీసుకున్నాను అనమాట, యాక్సెప్ట్ చేసినాను. యాక్సెప్ట్ చేసిన ఒక 10 నిమిషాలకు మీరు మళ్ళీ నా గిఫ్ట్ నాకు ఇవ్వండి అన్నారు. మీరు ఇప్పుడు నాకు ఎట్టుంటుంది? మళ్ళీ అపోజ్ చేస్తాను కదా నేను. ఇప్పుడు ఇచ్చినారు మళ్ళీ తీసుకుంటారు ఇవి రారు. అర్థమవుతుంది కదా? సేమ్ స్టోరీ విత్ కాయిల్ ఆల్సో. సో ఇట్ అపోజెస్ ఎవ్రీ టైమ్. వాట్ ఎవర్ చేంజ్ ఈస్ హ్యాపెనింగ్, ఇట్ విల్ అపోజ్. దట్ ఈస్ ద ఫంక్షన్ ఆఫ్ ఎ కాయిల్. Are you able to understand, ma? See, ma, previously north pole opposed the coil, it has opposed. And when it is nearer, okay, fine. Yattago chasing chesede undi. Now it is trying to move away. Then also it will oppose. Okay. Now what is the method of opposing? It doesn't want the north pole to move away, so it will develop a south pole. That's all very simple. Are you able to understand? So therefore, now what is the change happening now? Change is what? మార్పు ఏది అది చూడాలి మీరు ఎలక్ట్రోమాగ్నెటిక్ ఇండక్షన్లో. దేనివల్ల మార్పు జరుగుతూ ఉంది? చేంజ్ ఈజ్ హ్యాపెనింగ్ బికాస్ ఆఫ్ వాట్? అండ్ యూ హ్యావ్ టు ఇండ్యూస్ కరెంట్ అపోజింగ్ దట్ చేంజ్. క్లియర్ మా? నౌ చేంజ్ ఈస్ వాట్? నౌ చేంజ్ ఈజ్, క్లియర్ మా, మూవింగ్ అవే ఆఫ్ నార్త్ పోల్. ఓకేమా? బట్ కాయిల్ does not want the north pole to move away. Okay, so it opposes. And what is the method of opposition? Method of opposition is developing a south pole. Clear na? So this is one method in which we can explain the Lenz law. Are you able to understand? So previously north pole was approaching, it opposed the north pole. Now north pole is moving away, then also it will oppose only. దాని ఫంక్షన్ అపోజ్ చేయటమే అంతే. ఓకే, మీరు మంచి చేసినా అపోజ్ చేస్తుంది, అది చెడు చేసినా అపోజ్ చేస్తుంది అనమాట, అట్లా. సో వాట్ ఇట్ విల్ డూ హియర్? ఇట్ విల్ డెవలప్ ఏ సౌత్ పోల్. హియర్ ఇఫ్ ఇట్ ఈస్ సౌత్ పోల్, హియర్ a north pole will be developed. Are you able to understand? Now see, now we will study the second method of explanation of Lenz law, how it is opposing. One method we have understood, no? It develops a south pole. Second method is that, now see, this is north pole and these are the magnetic lines given by the magnet. Coil is somewhere here. Okay, ma? Now this is moving away. This has developed what? This has developed a south pole. Clear, na? And south pole means what? South pole means this is the direction of current. Correct? No? Current flows in this particular direction. If I look from this side, ఈ వైపు నుంచి చూస్తే కరెంట్ ఇలా కనిపిస్తుంది, వెనకల నుంచి చూసినారనుకోండి కరెంట్ ఇంకో విధంగా కనిపిస్తుంది. ఇఫ్ ఐ లుక్ ఫ్రమ్ దిస్ సైడ్, దిస్ ఇస్ ద డైరెక్షన్ ఆఫ్ కరెంట్ బికాస్ ఆన్ దిస్ సైడ్ ఓన్లీ సౌత్ పోల్ హ్యాస్ డెవలప్డ్. క్లియర్ మా? Now what is the property of south pole? Ma? South pole, in the south pole, magnetic lines are entering the south pole, no? What is the property of south pole? Magnetic lines enter the south pole. Now can you say how it is opposing the moving away of north pole? Chapandi. This method you have understood, no? Now with the help of magnetic lines, how can you say that this coil, it is opposing the movement of north pole? It doesn't want the north pole to move away. By magnetic lines, how can you explain? No. See, when magnet moves away, the number of magnetic lines which are touching the coil, they will reduce, no? Magnet దూరంగా వెళ్ళిపోతే magnetic lines, coilని టచ్ అవుతున్న magnetic lines ఏమవుతాయి? తగ్గిపోతాయి. But a coil does not want the magnetic lines to reduce. Are you able to understand, ma? So what it will do? It will induce its own magnetic lines, so that number of magnetic lines remains constant. That's it. Are you able to understand? So therefore what happens? If north pole moves away, okay ma, then number of magnetic lines reduce. Okay, but a coil does not want magnetic lines to reduce. Okay ma? So it will induce its own magnetic lines. It will induce its own magnetic lines such that number of magnetic lines remains constant. Okay ma? That is the method of opposition. రెండు మెథడ్స్ మీకు అర్థమైనాయి కదా, రెండు కూడాను మీకు గుర్తుండాలి, ఒక్కొక్క చోట ఒక్కొక్కటి యూజ్ అవుతుంది. It is not that by using one method you can do all the problems. No, you should remember all the methods, so each method will be used in each problem. Understood nama? So when magnet moves away, number of magnetic lines reduces, no, but a coil does not want the magnetic lines to reduce, so it will induce its own magnetic lines in the same direction, so that number of magnetic lines remains constant. Fine, that's it. So this is what is called as Lenz law. Okay ma? Therefore, what is the statement of Michael Faraday's second law? E is equals to minus d pi divided by dt. What does minus indicate? Minus indicates opposition. Okay ma? Minus indicates opposition. It means EMF is induced in that direction so as to oppose the change which is producing it. Okay, that's it. Sima, see this question. So in this, here there is a magnetic field. What does cross indicate? Magnetic field is inside the board. Always you remember by this arrow. Already I said, you know, when arrow is entering the board, you will see this cross. It means that magnetic field is entering the board. So this is the direction of B dash. Magnetic field entering the board. Are you able to understand? Now see. Now in this magnetic field, I am placing 3 coils and I am giving them a velocity of V. Okay. So this is one coil which is present inside the magnetic field. Now this is the coil which is leaving the magnetic field, and this is a coil which is entering the magnetic field. Now in these 3 coils, I want the direction of current. Current direction I want. Anybody? What is Lenz law? EMF is induced in that direction so as to oppose the change which is producing it. This is what we have studied. No? Now can you say, if I take this first coil, when it is moving in this uniform magnetic field, what is the change which is happening here? మార్పు ఏముంది చెప్పండి. When coil is moving in uniform magnetic field, what is the change? First coil. No change. There is no change at all. Why there is no change? Sima, when it is like this, consider some 100 magnetic lines are touching. And when it is moving in this magnetic field, same 100 lines are touching, no always. Clear, Nama? So number of magnetic lines which are touching the coil, they are not changing. So no EMF. Okay. So therefore here I say EMF is equals to minus d pi divided by dt. So minus 0 divided by dt, it is equal to 0. There is no EMF produced. Why EMF is 0? D pi is 0. Change in flux is 0. Clear, Nama? Okay. Now let us study about second coil. Now can you say what is the change which is happening? Change is what in second coil? Huh? Entering. So if it enters, what change happens? Flux increases or reduces? Increases. That is the change, no? See, if coil is entering, previously only some 4 or 5 magnetic lines are touching. But when it starts entering, many magnetic lines are touching, no? So it means number of magnetic lines which are touching the coil, they are increasing. So change is what? Change is, clear ma? Number of magnetic lines touching the coil are increasing. Okay ma? This is the change. But what coil will do? Coil ఆ మార్పుని స్వాగతిస్తుందా? It will oppose. That is the Lenz law. No? Whatever change happens, coil always opposes. Now can you say how it can oppose? How it can oppose? Number of magnetic lines which are touching the coil, they will increase. లోపలికి ఎంటర్ అవుతే మ్యాగ్నెటిక్ లైన్స్ పెరుగుతాయి కదా, బట్ ఇట్ డజంట్ వాంట్ ద మ్యాగ్నెటిక్ లైన్స్ టు ఇంక్రీజ్. అంటే ఎన్నికి వెళ్ళిపోతుందా? దానికే కాళ్ళు చేతులు ఉన్నాయి ఎవరే. ఇక్కడైతే బిర్యానీ తిని పడుకుంటుంది, ఇక్కడేం చేస్తుంది? ఎలా? హౌ? ఆపోజిట్ అంటే ఎలా చెప్పండి? ఆపోజిట్ మీన్స్ హౌ? Sima here, number of magnetic lines increases, no? But it doesn't want the number of magnetic lines to increase. So what it will do? It will try to flow current in that direction so that the number of magnetic lines always remains constant. Now, magnetic lines are entering, no? Magnetic lines are entering the coil and increasing. So what coil will do? Coil will develop magnetic lines exactly in opposite direction. Okay, ma? It means if I place my right hand like this and if I rotate my hand like this, right hand palm rule, then magnetic field will be out of the board, no? So these magnetic lines will oppose the magnetic lines which are present here. And these magnetic lines are developed by whom? Coil. If coil should develop magnetic lines in this direction, then what is the direction of current? Current should flow in this direction. That's all very simple. Are you able to understand, ma? కరెంట్ ఈ వైపు ఫ్లో అయింది అనుకోండి, అప్పుడు ఏమవుతుంది? దెన్ ఐ హ్యావ్ టు యూజ్ మై రైట్ హ్యాండ్ పామ్ రూల్. దిస్ ఇస్ ద డైరెక్షన్ ఆఫ్ మ్యాగ్నెటిక్ ఫీల్డ్ అవుట్ ఆఫ్ ద బోర్డ్. వై మ్యాగ్నెటిక్ లైన్స్ షుడ్ డెవలప్ ఇన్ ఆపోజిట్ డైరెక్షన్? సో దట్ ద నంబర్ ఆఫ్ లైన్స్ విచ్ ఆర్ ఎంటరింగ్ ద కాయిల్, దే షుడ్ గెట్ క్యాన్సల్డ్ విత్ ఈచ్ అదర్ అండ్ నంబర్ ఆఫ్ మ్యాగ్నెటిక్ లైన్స్ ఆల్వేస్ రిమైన్ కాన్స్టెంట్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? దట్ ఈస్ ద రీజన్. సో ఇట్ ఫ్లోస్ కరెంట్ క్లాక్ వైజ్, యాంటీ క్లాక్ వైజ్? యాంటీ క్లాక్ వైజ్. సో ఇట్ ఫ్లోస్ కరెంట్ ఇన్ anti-clockwise direction. Okay ma? So that induced magnetic field means whom? Magnetic field developed by coil. Induced magnetic field opposes the external magnetic field. That is the method of opposition. అర్థమవుతుంది కదమ్మా? సో డైరెక్షన్స్ ప్లేస్ ఎ వెరీ 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 ఇంపార్టెంట్ రోల్ మా. ఇఫ్ యు ఆర్ నాట్ క్లియర్ ఇన్ మ్యాగ్నెటిక్ ఎఫెక్ట్స్ ఆఫ్ కరెంట్, యూ విల్ నెవర్ అండర్స్టాండ్ ఎలక్ట్రోమాగ్నెటిక్ ఇండక్షన్. ఓకే, నా వాట్ అబౌట్ థర్డ్ కాయిల్? కెన్ యూ సే? ఇప్పుడు అదే స్టోరీని ఆపోజిట్ డైరెక్షన్లో చెప్పండి. థర్డ్ కాయిల్, కమాన్. ముందరికి పరిగెత్తినాం, రివైండ్ చేస్తే వెనక్కి పరిగెత్తాలి. ఇప్పుడు చెప్పండి, సేమ్ స్టోరీ ఎలా చెప్తారు? వెన్ ఇట్ ఈస్ మూవింగ్ అవుట్ ఆఫ్ ద కాయిల్, వాట్ హ్యాపెన్స్? అవుట్ ఆఫ్ ద ఫీల్డ్, వాట్ హ్యాపెన్స్? సో ఇట్ ఈస్ మూవింగ్ అవే ఫ్రమ్ ద ఫీల్డ్, నమ్మా. వెన్ ఇట్ ఈస్ మూవింగ్ అవే ఫ్రమ్ ద ఫీల్డ్, నెంబర్ ఆఫ్ మ్యాగ్నెటిక్ లైన్స్ టచింగ్ ద కాయిల్ reduces. Clear, no? So if number of magnetic lines reduces, what it will do? It doesn't want the magnetic lines to reduce. Oppose చేయటమే దాని పని, గుర్తుపెట్టుకోండి. అర్థమవుతుంది కదా? So it doesn't want magnetic lines to reduce. So what it will do? It will flow current in such a direction so that magnetic lines does not reduce. And how it is possible? Now magnetic lines entering the coil, they are reducing, no? So it will try to flow current in such a direction that magnetic lines again increase. So it is possible only if it flows current in clockwise direction. Now this is the direction of thumb. Why thumb is in this direction? Because magnetic lines should increase because of coil. Are you able to understand? That's it. So here only you can write third coil. Number of magnetic lines, they are reducing. Okay ma? So it flows current in clockwise direction so that induced EMF opposes the induced EMF helps the external magnetic field. Okay ma? Now it will help the magnetic field, external magnetic field, so that because it doesn't want the number of magnetic lines to reduce. పెరిగినా అపోజ్ చేస్తుంది, తగ్గినా కూడా అపోజ్ చేస్తుంది. అది దాని యొక్క ప్రాపర్టీ. క్లియర్ మా? ఓకే మా? See ma, here I am placing a coil and through the coil I should pass a magnet. సో మ్యాగ్నెట్ కాయిల్ ఇలా ఉందనుకోండి, దాంట్లోంచి మ్యాగ్నెట్ పాస్ అవ్వాలి. సో ఇట్ విల్ go out of this coil with how much acceleration? Beautiful options are given. You can select any one option. A value is equal to G, A less than G, greater than G. I cannot analyze because I am a donkey. Chappati. See ma, here. So through this coil, from the center of this coil, I should pass this magnet. No? That is the condition. Clear ma? So when I release it from the top, so if this is the what you call coil, now magnet is in this position. Now it is freely falling. Now when it is falling, what is the change which is happening? Marp emiti adi ఆలోచించు. Approaching of north pole. Approaching of north pole is the change when it is coming. But magnet does not want the north pole to approach. That is the change. No? That is its property. మీరు ఏది చేసినా అది అపోజ్ చేయడమే దాని పని. సో వాట్ ఇట్ విల్ డూ? సో వెన్ ఇట్ ఈస్ హియర్, వెన్ నార్త్ పోల్ ఈస్ అప్రోచింగ్, సో ఇట్ విల్ ఆల్సో డెవలప్ ఏ నార్త్ పోల్ ఆన్ ద టాప్. పైన ఏం చేస్తుంది? పైన నార్త్ పోల్ని డెవలప్ చేస్తుంది, కింద సౌత్ పోల్ని డెవలప్ చేస్తుంది. క్లియర్ మా? అండ్ వాట్ ఈస్ ద ఫోర్స్ ఆఫ్ టైప్ ఆఫ్ ఫోర్స్ బిట్వీన్ నార్త్ అండ్ నార్త్? Repulsion. So therefore if you take this magnet, clear ma, its own weight mg is acting downwards, no, and repulsive force is acting in this direction, no? So definitely it is not a freely falling body, no? Because additional force, opposing force is also acting, no? So definitely it is not a freely falling body, and its acceleration is definitely less than g. Clear no? So this is what happens when it is on the topmost position. Now whatever it may be, mg is greater than F repulsion, so magnet will pass through the coil. Now after passing, in the second condition what happens? Now this is the coil, now magnet is about to leave the coil. Now south and north will be present, no? When it has already passed through the coil, now south, now what is the change here? South pole is leaving the coil. उससे कहीं कुछ नहीं, उसका नज़दीक है, सो कौन से उसके बारे में बात कर रहा हो, ये क्या कि किलोमीटर दूर में है वो. Okay ba? Now the change which is happening is south pole is leaving the coil. Again coil does not want the south pole to leave. So what is the method of opposition? Producing north pole. Clear nama? Now above the coil south pole is produced, below the coil north pole is produced, because again it doesn't want the magnet to leave. అర్థమవుతుంది కదా? ఒక ఆడపిల్లని తీసుకొని ఒక దరిద్రునికి ఇచ్చి బలవంతంగా పెళ్లి చేసినారనమాట. చేస్తే చేసినారని అడ్జస్ట్ అయిపోయింది ఆమె. చిచ్చి వాడు మంచివాడు కదా, మళ్ళీ విడాకులు ఇస్తారంటే మళ్ళీ అపోజ్ చేస్తుంది ఆమె. అదే సేమ్ స్టోరీ ఇక్కడ కూడా. అర్థమవుతుంది కదా? ఎన్ని ఎగ్జాంపుల్స్ ఇచ్చినా మీకు ఎక్కడ లేదురా బాబు, అదే నా ప్రాబ్లం. అర్థమవుతుంది కదా? అపోజ్ చేయటమే దాని పని. ఓకే, దేవుడే కాపాడాలి మిమ్మల్ని. ఓకేమా? నౌ సౌత్ పోల్ ఈస్ లీవింగ్ అండ్ కాయిల్ డస్ నాట్ వాంట్ ద సౌత్ పోల్ టు leave, so it will develop a north. Now what are the forces which are acting? Now mg is acting in this direction and force of attraction is acting in this direction. Whatever it may be, mg is supposed to know, so again a value will be less than g only. So when it is entering, a is less than g. When it is leaving also, a value is g. This is one beautiful explanation of Lenz law. Clear? Okay. Same. So next we are studying about magnetic flux. What is meant by magnetic flux? For example, if you take an unit area, out of this area how many magnetic lines are traveling, that is called as magnetic flux. Are you able to understand? How many magnetic lines they will cross an unit area, that is called as magnetic flux. See, so how to draw area vector? For example, if it is a surface, outward drawn normal is called area vector, no? This is A dash. This is how we draw area vector, no? For example, if it is a mobile phone, how can I draw area vector for this surface? Outward drawn normal. This is how we draw area vector. Clear? Now, if this is the direction of B dash, magnetic field is also in the same direction. In this particular region, magnetic field is also in the same direction, area vector is also in the same direction. Then I can say that how many magnetic lines are crossing this unit area, that is given by flux is equals to B into A. This is the equation to calculate magnetic flux when area and magnetic field, both of them, they are in the same direction. Are you able to understand? Now see, in the second condition, consider this is area vector. Clear ma? Area is like this. But consider magnetic field is like this. This is the direction of B dash. Okay? So field emo ila veltundi, area emo ila veltundi. Okay. Now what is the angle between both of them? Angle between both of them is theta. Okay. Now in this condition, how can I calculate flux? Split. So take this B dash. Clear ma? Split this one into two components. Clear no? So if this is angle theta, this is B cos theta and this one is B sin theta. So therefore, which two components I am supposed to take? Those two components which are present in the same direction. So here, B cos theta and A dash, they are in the same direction. No? Are you able to understand? No? B cos theta is horizontal direction, A dash is also in horizontal direction. So therefore, you are supposed to take B cos theta multiplied by A. This is how I calculate flux. Okay. So this is of which form? This is of AB cos theta form. Clear no? Or you can write in dot product form also, no? A dash dot B dash we should not write. Or we can write, no problem. Okay ma? So B dash dot A dash. This is how I can calculate flux. Are you able to understand ma? This is a general relation. You can use for any angle. You can use here also. Here angle between A dash and B dash is how much? 0. So apply flux equation. BA cos 0. Cos 0 value? 1. So B into A. So again I got the same equation. Are you able to understand? So this is the general equation. Flux passing through an unit area is BA cos theta. Okay? Are you able to understand? So therefore, pi is equals to B dash dot A dash. This is the general equation to calculate flux for any angle. Whatever may be the angle, always you can use this relation. Are you able to understand? Okay. Now, here I will take one case. Case is if surface is irregular or surface is a curved surface. What is the case I am taking? Case is that surface is irregular surface or surface is a curved surface. Clear? So what is the meaning of this one? Consider an area is like this. So for this area, how can I calculate how much flux is passing through this area? Previously we have taken a regular surface, no? But this is somewhat a curved surface. So in this condition, what I do is I take a very small area here, which I can call it as dA dash, very small area. Okay. So through this small area, the field which is traveling is B dash. And because area is very small, flux also will be very small. No? So d pi is equals to B dash dot dA dash. I can write like this. Are you able to understand what is happening? So this is a regular surface. This is a very small surface which I have taken. So because here there is no particular direction for area, no? So here if you see, here area is in this direction. Here area is in this direction. Here area is in this direction. There is no particular direction. So what I do is I take a very small area, dA dash, and the flux which is passing is B dash. Because area is very small, flux traveling also will be very small. So d pi is equals to B dash dot dA dash. Differential flux. It means very small amount of flux. Now if I want to total flux through the area, then what I have to do? Integrate on both sides. Total flux through surface. I have to integrate on both sides. So integration of d pi is equals to integration of b dash dot dA dash. So integration and differentiation will get cancelled. So therefore pi is equals to, or you can say closed integration of b dash dot dA dash. Closed integration means what? Integrating throughout the surface. Are you able to understand? Ma? So this is the equation to calculate flux, in which condition if area is not regular. If it is a regular surface, direct formula. If it is an irregular surface, then you have to use integration. Okay? That's it. Okay, Sima. So a coil of 100 tons is linked by magnetic flux of 20 milliwebers. Clear? Ma? So if this flux is reversed in a time of 2 milliseconds, then calculate the average EMF induced in the coil. This is the question. Okay, ma? See what are the data which is given. Number of tons he gave, 100 tons. In this coil, how many tons are there? 100 tons are present. So initial magnetic flux is how much? 20 into 10 power minus 3 webers. Milliwebers he said, no? So 20 into 10 power minus 3 webers. Then what is happening? This flux is reversed. Reverse means what, ma? So initially this was the coil. Flux was traveling in this direction. Immediately what happened? Flux direction has changed. Okay. So this is also a change, no? Change should happen. If a change happens, EMF will be produced. Definitely direction has changed, no? Definitely EMF will be produced. So therefore, pi 2 value I can say, can I say minus 20 into 10 power minus 3? That's all, no? Clear, no? Therefore, what is the time taken? So this reversal is happening in how much time? So in a time of 2 into 10 power minus 3 seconds. Then calculate the EMF induced. EMF induced, how can I calculate? Minus n d pi divided by dt. This is the equation, no? Clear, no? So minus n d pi, what is meant by d pi? Change in flux. Change in flux can be written as pi 2 minus pi 1, no? Divided by time taken. I can write like this, no? Are you able to understand? So therefore, now substitute all the values. E is equals to n value is 100 minus 100 multiplied by pi 2 value is minus 20 into 10 power minus 3 minus pi 1 value is 20 into 10 power minus 3 divided by time taken is how much? Time taken is 2 into 10 power minus 3. Minus minus will get cancelled. So 20 plus 20, 40. 40 into 10 power minus 3 multiplied by 100 divided by 2 into 10 power minus 3. So minus 3 get cancelled. 4000 by 2 is 2000 volts. That is our answer. Okay, ma? So therefore, if a flux reverses in this much of time, then this much of potential difference will be produced in the circuit. Okay? That's it. Okay. See. Now we are discussing about methods of inducing EMF. How many methods are there so that I can induce EMF in the coil? Okay, ma? EMF means potential difference so that current flows in the coil. Sima, EMF is induced in which condition? When flux changes. When flux linking the coil, when it changes, then EMF will be induced. And flux depends on how many factors? Subarav, Vinali. Notes రాయడం కోసం కాదు క్లాస్కి వచ్చేది, వినండి. Flux depends on how many factors? Strength of magnetic field, area of the coil, angle between magnetic field and area vector. So flux depends on 3 factors, no? So therefore EMF induced also depends on 3 factors. That's all. Are you able to understand, ma? See, ma, if strength of magnetic field changes, if a strength of magnetic field changes, definitely flux will change. If area of the coil changes, then also flux will change. Similarly, if angle between magnetic field and area vector changes, then also flux will change. And if a flux changes, EMF will change. That's all. Are you able to understand? For example, see the first case. Case number 1. Okay, ma? See here. So this is a coil and this is the magnetic field which is present. So flux entering the board is decreasing with respect to time. Okay, ma? Now can you say what happens here? This is a coil. Clear, ma? Initially, how many magnetic lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 magnetic lines are there. Now, what is happening with respect to time? First 8 lines will become 7, 7 will become 6, 6 will become 5. So, like this, which is reducing here? B value is reducing. If B value reduces, can you say what happens? If a B value is reducing, it means definitely flux will change, no? The number of magnetic lines which are touching the coil, they will change. If a flux changes, definitely EMF will be produced. If EMF produced and if it is a closed coil, current will flow. This is a closed coil only, no? Current will flow or not? Will flow. Can you say what is the direction of current? Current direction. Current లోపలికి పోదు, ఈ కాయిల్లో తిరుగుతుంది. ఎలా తిరుగుతుంది? Clockwise or anti-clockwise? Clockwise. How can you say? Anti-clockwise. How can you say? What is the change which is happening here? Huh? Decreasing of flux. That is the change, no? But a coil does not want the flux to decrease. So what it will do? It will develop flux in the same direction. Are you able to understand, ma? Here flux is perpendicularly inside the board, no? And flux is reducing. Coil does not want the flux to reduce. So in the same direction, it will induce additional magnetic lines. How it is possible? Only if I curl my finger like this. Thumb is perpendicular and inside the board. Okay, ma? So therefore, clockwise direction should be the direction of current. Then only field induced will be perpendicular and inside the board according to right hand palm rule. Okay? So this is my first change. Are you able to understand? Let us see one more change. Area. See here, case number 2. Okay? So initially this was a coil. Clear, ma? And this coil I have converted into a circular coil. Area will change or not? So wire, it was previously present in the shape of a square. I have converted this one into a circular coil. Area, will it change or not? Definitely area changes. Clear, ma? Area changes. And if area changes, flux also changes. Flux linking the coil. Flux linking the coil changes. And flux linking the coil, if it changes, EMF is induced. Okay? So by changing area of the coil also, you can induce magnetic field. Okay, you can make EMF to be induced. Okay. One more method, case number 3. Case number 3. Okay, ma? See, previously considered this is the direction of magnetic lines B dash. Coil was like this. Coil was like this. Now how many magnetic lines are touching this coil? 3 magnetic lines are touching. Now after some time, I have made this coil like this. I have shifted this coil by an angle of theta. Now how many lines are touching? Only 2 lines are touching. So number of magnetic lines which are touching the coil, it is changing, no? By changing what? By changing angle. If I change this theta, then flux also will change. Then definitely again EMF will be induced. This is the third method of induction. Are you able to understand? So here what is happening? Angle changes or orientation of coil changes. Flux linking changes. Flux linking the coil changes. And EMF will be induced. EMF will be induced. So these are the 3 methods by which flux can change and EMF can be induced. Clear? That's it. Student. See, here what is happening? This is a coil in which some resistance is also present. And what does this cross indicate? Now, magnetic lines are entering the board. And when you see the flux here, 6t square plus 70 plus 1, what do you understand? It is changing with respect to time. No, flux is not variable. So is it increasing with respect to time or decreasing with respect to time? ఫ్లక్స్ పెరుగుతుందా తగ్గుతుందా? If time increases, flux increases, no ma? If you go on increasing the time here, definitely flux increases. So flux which is entering the board increases. So first of all, let us calculate third question, direction of current. Can you say the direction of current? If anti-clockwise, how can you say? Okay, ma? If magnetic lines are entering the board and they are increasing, coil does not want the lines to increase. So what it will do? It will oppose the lines. And what is the method of opposition? If current flows only in this direction, then only field produced by the coil will be out of the board. Are you able to understand? So therefore, what will be the direction of current? This will be the direction of current. So here this is the current direction, like this, like this. This is my direction of current, and that is my answer for third one. Are you able to understand? So Lenz law says that current always flows in that direction so as to oppose the change. Change is increase of flux. So it will try to make the flux to be constant. It is only possible if I pass current in this direction. Are you able to understand? Current will be induced in this direction, anti-clockwise direction. Okay? Now see. So therefore, first question what he is asking, at t is equal to 2 seconds, find the EMF induced. So EMF induced he is asking. Already we have relation number minus d pi divided by dt. So just I will calculate magnitude only. So E is equals to d by dt of flux. What is the flux value given? 6t square plus 7t plus 1. Okay, ma? So differentiation of 6t square is how much? 12t. Differentiation of 7t is 7. Okay. So this is the EMF which is produced. Now at which time I want to calculate flux? At a time of 2 seconds. Now you are supposed to substitute 2 seconds. तो मैं क्या करी हती तो हाँ 2 से डिवाइड कर डाले हती होता है सर? हाँ वो तो सुपर इंटेलिजेंस वैसा करती करवा ये तो मैं मामूल मनुष्यों इट्ला చేసుకుంటా हाँ 31 is correct. So EMF is equals to 12 into 2 plus 7. Okay, ma? So 24 plus 7 is how much? 31. Okay, and flux is given in milliwebers, no ma? So units also millivolts. Flux is measured in milliwebers. Potential difference is measured in volts, no? So millivolts is my answer. So this much amount of EMF will be produced in the coil. Now see what is the next question. If R value is 31 ohms, resistance of this circuit is 31 ohms, then what is the current produced? Can you say? How to calculate second question? Ohms law is there, no? I is equals to V by R. Okay, ma? What is the EMF produced? 31 into 10 power minus 3 divided by resistance is 31. So I value is how much, ma? 10 power minus 3 amperes. This much amount of current will flow in the coil. That's it. Have you understood? Very simple.